In this video, I'm going to be talking about Snell's law and refraction. Refraction is the bending of light as light enters a new medium. So when it enters a new medium, it may or may not change its velocity. Chances are it will have a slight change in velocity, and that bending of light is called refraction. So there's a number to measure this, which is n. That's called the index of refraction, and it's a ratio of c, the speed of light in a vacuum, which is 3 times 10 to the 8th meters per second over v, and v would be the velocity of light through a certain material such as water or glass. So let's take a look at two sample problems and we'll see how to apply Snell's law. Snell's law is basically this formula right over here where we have an index of refraction and the angle that the light is moving through it, and then a second index of refraction for the next medium or the next material and the angle that light moves through that material. So first of all, I would suggest drawing a picture. So I'm just going to draw a line to show where it's hitting the surface, and then I'm going to draw a dashed line perpendicular to it, which is known as the normal. The normal is just an imaginary line perpendicular to that surface, and it's just used as a reference so we know what our theta is, our angle. So the question says light moves through water and strikes glass at an angle of 46 degrees. So I'm going to put the 46 degrees for my first angle, and I'm going to label this as water. And then the light bends at an angle of 39 degrees, so it bends a little bit closer to the normal. It doesn't really matter too much how accurate your picture is. It's just more for labeling and organization. And then it says, what is the index of refraction of the glass? So I'm going to go ahead and make sure I finish labeling it, the glass. If the water has an index refraction of 1.33. So we know that this one has an n value of 1.33, and then this is our unknown, the index refraction of this particular glass. Now, it's a pretty easy rule. The rule is everything on one side of the formula pertains to the numbers of one specific type of material or medium. So for the N1, we got 1.33 times the sine of 46 degrees. And then on the other side is all of our values for glass. We don't know our index of refraction, so I'm going to go ahead and write N2, and I do know the angle, so I'm going to write sine of 39 degrees. So from there, the math is pretty simple. It might look a little bit more intimidating because it has a trig function in there, but remember, sine of 46 and sine of 39, they're just numbers. They're just not a number you probably know off the top of your head. So you can go ahead and divide both sides by the sine of 39 degrees. And you're done. So my n value is going to come out to 1.52. Okay, and that value doesn't have a unit because there are two different velocities divided by one another, which I showed over here. So the units end up canceling out. So the index of refraction of that particular type of glass is 1.52. So you're normally looking for a number that is fairly close to 1. Something like a diamond over here has a fairly high one of 2.417, but typically you're going to find an index of refraction of around 1. So if you're getting something strange like 52.5, that's probably going to be a little bit too high, and you want to go back and check your algebra. All right, let's take a look at our second problem. Our second problem, I'm going to start off the same way. I'm going to go ahead and put a line where the surface is. I'm going to go ahead and dash a line for my normal, the line that's perpendicular to the surface, and then I'm going to go ahead and label it as I read the problem. So an incident ray of light travels through plastic at 19 degrees, 90-degree angle towards water. If we know the index of refraction of the plastic is 1.9, so we know that its n value is 1.90, then what is the angle of refraction when entering water? So we don't know our theta 2, our second angle. And we do know the index of refraction of water over here is 1.3 repeating. So I'm just going to go ahead and label that as water. And then I'm going to round that off to 1.33. So same as we did last time, everything on one side of the equation is going to pertain to one medium. So on the left side, I'll make that my plastic side. So 1.9 times sine of 19 degrees equals 1.33 times the sine of theta 2. Now for this one, it isn't much more complicated than the first one, but slightly if you've never seen this before. So we're going to go ahead and divide each side by 1.33 to try to isolate my theta. And that gives us a value of about 0.465. So if you want the value for theta, you have to use the inverse trig function. So you have to take the inverse sine of 0.465 in order to find it. And then once you plug that into your calculator, you're going to get a value of about 27.7 degrees. And that's your final answer. Okay, so to sum things up, when you are working on a Snell's law problem, I highly recommend just drawing a picture, and that's mostly for the sake of organizing your numbers. Once they're organized, as I said before, everything in one medium goes on one side of the equal side, and all of the numbers for the second medium go on the other side, and then it takes a step or two of algebra, and then you're going to find your index of refraction or your theta. Thank you for watching and listening.